The next thing is a verification of Faraday's Faraday's first first law of electrolysis. So we want to verify it experimentally. So what we use, let's see the diagram first of the experiment. Diagram. We have copper cathode and anode. This is a copper 2 sulfate, the copper 6 solution. This is a copper anode. This is a copper cathode. We have the P, we have the source, we have the ammeter, we have the rheostat. We have the rheostat. That's the diagram. Plus, minus, this is the key. This is cells or battery. This is ammeter and the rheostat. That's the experiment. Then explanation of this experiment. So cathode and anode are weighed before the experiment. As M1 and M2 respectively. So this is the mass of cathode before experiment, mass of anode before the experiment, that is before electrolysis. So immediately after that, the key is closed. The key is closed and the rheostat is adjusted to the maximum reading of the ammeter, so that the maximum current will flow through the circuit. It's adjusted so that the maximum current will flow through the circuit, and the ammeter reading is read and recorded. So the maximum ammeter reading is recorded as I. The maximum ammeter reading is recorded as I, and the time taken as t in seconds. So the quantity of electricity is evaluated as Q equals IT. So the cathode and anode are weighed after electrolysis as M3 and M4 respectively, and the mass of copper deposited at the cartridge is evaluated as M equals M3 minus M1 gram, or M is equals to M2 minus M4 gram. This one is telling us that the mass of copper deposited at the cartridge is equals to increase in mass of cartridge, which is also equals to decrease in mass of anode. Take note of that. So the experiment is repeated 4 or more times by adjusting the rheostat. In each case, ammeter reading is recorded as I, and time taken for the current to flow, and time taken T in seconds is recorded as well. So M, in each case, M and Q are evaluated as well, as shown in the table below. We have the table like this. This is serial number. This is current I in ampere, time in seconds. You know, Q is equal to IT, which is in coulomb, and you have the mass M, which is in gram. So the graph of M is plotted against Q. The graph of M is then plotted against Q, and a straight line graph is obtained as shown below. So sketch the graph. You have M here, you have Q here, you have a straight line graph. So this shows that mass of substance deposited is directly proportional to the quantity of electricity. That is what you have, to the quantity of electricity. So in case, take note of the following. All these are special notes. In case you have to determine to perform an experiment to determine electrochemical equivalence, you have to find the slope here, change the hem, change the key. So the slope S is equals to change in hem or change Q. What is in M? You could say Z to represent electrochemical equivalence. So the slope of mass of the source position at the electrode against quantity of electricity passed will give electrochemical equivalence. It's equivalence to electrochemical equivalence. That is one. Two, mass of copper deposited at the cathode is equal to increase in mass of copper cathode. Take note of that. So here we represent M equals, use M3 minus M1 gram. This is a mass of cathode after electrolysis minus mass of cathode before electrolysis. Please take note of it. It means mass of cathode after electrolysis minus mass of cathode before electrolysis. Take note of that. Take note of it. That is not number. Mass decrease in mass of anode is equals to mass of anode before electrolysis minus mass of anode after electrolysis. As you know that anode will dissolve, so the mass before is usually greater than the mass after. So before, remember from that experiment is M2, after is M4, so it will be in gram. That is decrease in mass of anode. So number 4, it was observed that increase in mass of cathode is equals to decrease in mass of anode, which is equals to mass of copper deposited at the cathode. Take note of that. So this is what we are saying. M3 minus M1 gram is equals to M2 minus M4 gram, then is equals to mass of the substance deposited. These are the things we need to know. So we are going to look at a question to illustrate that. So let's see question.